Hello friends, this question is from the test series number 10. Subject name is network, topic name is studies, sinusoidal steady state. It's a 2 marks problem. In a question we have one RLC network and we need to find out the current across this 2 ohm inductor, or we need to find the value of current I. That is, we need to find out. You can see that in the problem in the circuit we have 3 energy sources. There are 2 current source and 1 voltage source. So if you can see that this current source 2 sin 10 raised to power 5t is basically have a peak value of 2, to its RMS value will be 2 by root 2, or I can say this, it is equal to the root 2, right? While here in this other current source has a magnitude of 2 cos 10 raised to 5t. So we know that the sine and cosine have a phase difference of 90 degrees, so I can write it down as a 2 of sine of 10 raised to power 5t plus 90 degree, or I can say that the peak value, the RMS value of this signal is 2 by root 2 with the angle of 90 degree, or root 2 with angle of 90 degree. Similarly, here we also have a one voltage source which has a magnitude of under root of 32 cos of 10 raised to power 5 plus 45 degree. So under root 32 is basically, under root of 32 is 16 into 2, which is 4 root 2, right? So I can rewrite it as a 4 root 2 cos of 10 raised to power 5t plus 45 degree, or I can again write it down as a 4 root 2 sine of 10 raised to power 5t plus 135 degree. 135 because I have converted cos into sine, so there is a 190 degree phase shift. We already have got the 45 degree phase shift earlier, so it is a total of a 135 degree phase shift. So my voltage source has a magnitude of 4 root 2 and a phase difference of 135 degree. So if you can look at the circuit, the question says that the current across the inductor is I. So if the current across the inductor is I, so I can apply KCL here. So current across this branch must be equal to, because we have the total current of as a root 2, so this must be root 2 minus I, right, across this voltage source. So we know that if the voltage source always uh, emit the same amount of current, both the terminal across the voltage source has the same current, so current across this branch is also equal to the root 2 or angle of 0 minus I. And this source, this again another current source which has a magnitude of 2 cos 10 raised to power 5t, which is basically emitting the effective current of root 2 with angle of 90 degree. So I can say that the current across this capacitor must be equal to, the current across the capacitor is basically root 2 9 with angle of 90 degree plus root 2 with angle of 0 degree minus I. It is the current across this capacitor. So here we can see that we know the current across the inductor, which is I. We know the current across the capacitor, and it is a voltage source. So if I want, I can apply the KVL in the upper loop, right? So let's apply the KVL in the upper loop. So my KVL equation must be equal to like that, 4 with angle of 135 degree plus into with a voltage source plus across the capacitor, which is total effective current is 2 with angle of 0 plus root 2 angle of 90 degree minus I into reactance, which is given as a minus j1 and minus of j2, which is the reactance of inductor, into current I. So this whole is equal to 0. So if I equate this to 0, now just after further simplification, my equation turns out as 4 with angle of 135 degree plus root 2 with angle of minus 90 degree plus root 2 with angle of 0 degree, which is basically equal to the 2 of root 2 of 45. So basically my current I is equal to root 2 sine of 10 raised to power 5t plus 45 degree, right? Because I'm taking the peak value of it. So my correct option is option B. Option B is here is the correct option. Thank you.